Hey, fellow problem solvers, Colfax Math here. Today we're working our way through our book, Math Test Success. Great news, I finally got it uploaded. It's not 100% edited, but the chapters to this video and prior will be edited down. You could get access to that book free of charge. There's a link in the description, mathtestsuccess.com. You just go to that webpage. There's a link on there and you could download the book in PDF form, all free of charge. If you really like it and it's helpful to you, feel free to share it with anybody else you know who is trying to do well on any standardized math exam. This series is really to help teach the ideas and skills for the ASVAB military placement exam, but they are the same for any kind of introductory math class, so you do well on any exam, whether it's a union entrance exam or you're going back to college. These are the essential skills you need. Today we're working on chapter 11. You can follow along in the book you printed out. You could also buy that book on Amazon if you want, and as well if you want to support the channel, please feel free to do so. My kids told me the best way to do all of this is just make it all free. My goal is really to make everybody more successful on any math so that they could get back in the game. And the goal of this book is for me to do that alongside of you. So you work your way through the book as you watch the video. So today we're working on chapter 11, Exponents and Radicals, watching the videos, looking at the book help. But what really brings it home is you doing the problems. Pausing the video, do the problems before I do them, take notes. All of that work with that pencil and paper is what really makes that stuff stick and make sense. You can't learn to juggle watching me juggle, you got to practice. Same thing with math. So with that said, let's go ahead and get started on chapter 11. Let's start talking about exponents. So what an exponent is, this is going to be a long chapter, there's a lot here, and one of the trickier chapters, but really a big part of any standardized math exam. 3 caret 4, that is the same thing as 3 to the power of 4. That's how you write it on a computer. So 3 to the 4, what that is it is saying 3 times 3 times 3 times 3. So the base is 3, the exponent is 4, and it tells you how many times you multiply it by itself. So the definition of it is if you have a to the n, a is your base, you're going to write this out n number of times, whatever that is right there. Okay, there are a lot of rules to go along with exponents. And I'm going to go through these here. The intent is you have this book in front of you and you're taking notes on it. So I leave these areas blank. If you don't have that book out or you don't have it, make sure you're taking notes in your notebook. The product rule is when I have something like x to the power of m times x to the n. Product means multiplication, and I am multiplying things together. One deal on the product rule and all of these rules, your bases have to be the same. So these are both x's. This rule says you keep that base x and you add those exponents together. So if I have x squared times x to the third, that is equal x, add them together to the fifth. The quotient rule is division. So if I have x to the m over x to the n, again, the bases are the same, I subtract the exponent. So that is equal to x m minus n. Or again, if I had x squared over x to the third, that would be equal to that same base of x, 2 minus 3, negative 1. The power rule is x to the m to the power of n. Then I multiply to give me x to the m times n. Or as an example, x squared to the power of 3 is x to the 6. Okay, the 0 exponent rule. If I have anything to the 0 power, it will always be equal to 1. It's a hard thing to remember. You think it's going to be 0, but it's equal to 1. So 5 to the 0 is equal to 1. 72 to the power of 0 is equal to 1. So the thing to remember is anything to the power of 0 is always equal to 1. The negative exponent rule, so if I have x to the negative 7, I can make it positive by reciprocating it. So what that means is I can make that exponent positive by putting it in the bottom. And the opposite of that is true too. So if I have 1 over x to the negative 7, like this, I can make that positive by reciprocating it. That's x to the 7 over 1. So again, the zero exponent rule, anything to 0 power is equal to 1. The negative exponent rule, you could always make that exponent the opposite sign by reciprocating it. So if it's a negative in the top, it's a positive in the bottom. Or if it's a negative in the bottom, it can be a positive in the top. A lot of rules here. Let's take a look at some examples. So here's simplify. What we want to do right here is we are using the product rule, x to the 8th times x squared. Bases are the same. That'll be equal to x to the 10th, 8 plus 2. Same here, multiplying, bases are the same. This is equal to x to the 8th. And right here, we have a couple things going on. I could do this two different ways here. First thing I could do is inside the parentheses, the bases are the same. 7 minus 4, that's the quotient rule. I have y equals 7 minus 4 to the 3rd. So this inside thing becomes that to the power of 2. Now I am multiplying with parentheses, and that becomes y to the 6th. All right, let's keep moving on here. There's a few more samples. This one right here, I have x squared, the whole thing to the power of negative 4. That's equal to x to the negative 8. Now I got to use the negative exponent rule. I want to make that positive by putting it down below. Your answers are usually always left with positive exponents. Number 5 is a little tricky because that 2, that square, is related to the 3 and the x, everything in the parentheses. So this is equal to 3 squared x squared. 3 squared is 9, so this is equal to 9. Uh-oh, pen's 9x squared. That's a good ASVAB problem to make sure you remember to distribute that 2 through the whole quantity. Okay, there's some more practice problems right here. Go ahead and pause the video, do these problems on your own. Unpause the video and watch how I do them. So number 1, I am multiplying. My bases are the same. This is equal to x to the 7th because I add the exponents. But number 2 is different. The quantity to the power of 4. Here I multiply to get x to the 12th. These are big. You really need to know these for the ASVAB exam. There's quite a few of these in the arithmetic reasoning and the mathematical knowledge, both. 2 to the 3rd, got to distribute that 3 through quantity 2 times 2, 4 times 2, 8. So 2 to the 3rd is equal to 8. B to the 3rd is b to the 3rd. Negative 2 has to get applied to both here. 3 to the negative 2, d to the negative 2. Then they're being multiplied. I'm going to make them positive by putting them down here. And then 3 squared is 9. So I have 1 over 9d squared. Here I am multiplying, so I'm adding. So my bases are the same. That is important. I add 3 plus negative 7 gives me negative 4. It's a negative exponent. Make it positive. I reciprocate it. Number 6 right here, I add those exponents to get n to the negative 9th, which is equal to 1 over n to the 9th. All right, let's get a few more here. See what we have. Again, pause the video, do the problems first. So I have to distribute that 4 to the whole quantity, giving me x. 2 times 4 is 8. X 3 times 4 is 12. These things are being multiplied together. Now I add to get x to the 20th. Get a little harder here. It looks like a lot going on. But let me just work on pieces at a time. I have 3 over 27, right? So 3 goes into 3 one time. It goes into 27 9 times. X to the 2 over x to the 1. 2 minus 1 is 1. On the y's, 7 in 2, y to the 7th over y squared is y to the 5th. And then here I have z to the 0. That whole thing's equal to 1. But I'm going to keep it as z to the 0. 0 minus 3 is z to the 0 minus 3, negative 3. I don't want negative exponents, so I'm going to have to put that down below. So that's going to give me x, y to the 5th over 9z to the 3rd. Okay, number 9 right here. Same thing. I'm going to set this up. 2 goes into 2 one times, into 8 4 times. A squared over a to the 6th is a to the negative 4th or a to the positive 4th down below. B to the 4th over b to the 3rd is b to the 1st. C to the negative 2, there are no other c's here. I'll just put c to the positive 2 down below. So learn those rules first, really get them down, and then you got to practice them to remember them and apply them is the best way. Right, let's take a look at radicals now. These are the inverses or the reverse operation of a square. So remember, if I have 6 squared, that is saying 6 times itself. And I go 6 times 6 is 36. A radical is the opposite. Radical 36 is not saying what times itself equals 36. It's saying go backwards. That's what an inverse function is go backwards. What times itself equals 36? The answer is going to be 6. So that's what a square root is. A square root is the most common one you'll see. It is saying what times itself twice will give you 36. All right, so it's a reverse of a square. But in addition to a square root, you could have a cube root, just like you would have 5 to the 3rd. That's equal to 5 times 5 times 5. 5 times 5, 25, times 5, 125. A cube root, you put that 3 right there, is saying what times itself is equal to that value. So if I have the cube root of 27, the answer is going to be 3, because 3 times 3, 9, times 3, 27. So I could have a square root. I don't write any number there at all. It's implied it's a 2. I could have a cube root, or I could have any size root. I could have the 4,000th root, right? What that's saying is what times itself 4,000 times will be equal to that. Simplifying radicals. Let's go through some of these rules, some practice problems here. First thing is to make sure you understand what a square is and a square root is. Square is you take that number, multiply it by itself. Square root is you're saying what times itself equals that number going backwards. And that's why we're doing exponents and roots or radicals at the same time. The product rule for radicals, saying if I have the square root of AB, that'll be equal to the square root of A times the square root of B. So I could always split these up into whatever numbers I want. It's common to split them up like this. If I have the square root of 50, I'm just looking for the factors of 50 until I get to a square, right? So 50 is made up of a 25 and a 2, right? 25 times 2 is 50. I could keep going with this and say 5 times 5, but I only go till it's a square, and I recognize it. Now this is equal to the square root of that 25 times the square root of 2. Square root of 25 is a 5. Square root of 2 stays like that. So you could simplify the radical square root of 50 to 5 root 2. That's also true in division as well. So if I have the square root of 64 over 9, that's going to be equal to the square root of 64 over the square root of 9, which will be 8 times 8 is 64. 3 times 3 is 9. So here, this is a little tricky one here, how you simplify it. But if I have the square root of x to the third, and you can see how this is going to test your skills in algebra here. X to the third is made up of an x squared and an x. Every square comes out, leaving me with no square for that one on the inside. Okay, it's a lot there. Let's do some of these practice problems here. Again, pause the video. Trying to do these problems, you can see why the multiplication table is so important to have that thing perfectly memorized. Okay, a 12, I see that made up as a 4 and a 3. A 4 is a perfect square. They're a pair of 2's. So the square root of 4 is equal to 2. No pair for that. It stays in. 48 is made up of a 24 and a 2, but that's not a perfect square. It is also made up of a 16 and a 3. 16 is a perfect square. Square root of 16 is 4 root 3. 50 is made up of 5 and 10. And I could do those, but it's also made up of a 25 and a 2. Perfect square, 5 root 2. Let me do this. That's a good way to do it, but I'll do it another way too. I have the square root of 50. Say I see it made up as a 5 and a 10. 10 is made up of a 5 and a 2. Here's a pair, 5 and a 5. So that for every pair, one comes out. No pair for that one, it stays in. So you could do it either way. It's going to be easier if you could break it into a perfect square or not. But if you don't see it, you could do it this way. It'll work out the same. Oh, I wrote that one down twice. Again, that's a 4 and a 3. So this is 2 root 3. Square root of a square. Well, that's x times x. So this is just going to be x. And then number 6, I have x cubed. That's going to be made up of a x squared and an x. Remember, I add those exponents. Here's that pair, x times x. So this is equal to x times root x right there. Okay, number 7, a to the 5th. This is a little trickier. This is going to be made up of a squared. That's going to give me 4a to the 1st, right? Remember my rules of exponents, I add across the top. That gives me a to the 5th. For every square, one comes out. That's that one. Another one comes out. A times a. No pair for that one, so it stays in. Number 8 right here. 16 is a 4. Y to the 3rd is y times y. But that third y has to stay in. Then on number 9 here, let's split this thing up. It's made up of a 16 and a 3. An x is x squared and an x. Y to the 4th is y squared and y squared, right? You add those exponents, get y to the 4th. Now I'm looking for every pair to take one out. 16 is a pair of 4s. There is no pair for that 3. X squared, one comes out. There's no pair for that one, it stays in. Y comes out for that's a pair. Y comes out, y times y is y squared. Pretty tricky. Moving pretty quick here. Make sure All right, let's move forward now to rational expressions. And this is going to take all those previous pieces and put them all together here. Again, this is a big part of the mathematical knowledge. This is kind of a standard like intro to algebra class and algebra class, and then you use it through all levels of math. So rational expressions is we're going to be taking our square roots and our exponents and putting them together. So if I have x to the power of 1 over 2, 1 over n, let's take a look at this. This is equal to the square root of x. There are no numbers written here, but if there's no number, it is implied that is a 1. No number written here is implied it's a 2. So if I have a square root like this, this is equal to my base to the power of a fraction, that over that 1/2. So if I have 9 to the power of 1/2, that is the same thing as the square root of 9, 1 over 2 there, right? And that's equal to 3. Another part of this is every time you take the square root, it is always positive or negative, because -3 times -3 is 9. So this could be a positive 3 or a negative 3, but you almost always leave that out. You use this a ton in the Pythagorean theorem to find the third side of a triangle. That length cannot be negative, and that's why you discard that negative. So that kind of is the easiest one when it's to 1/2 power, converts right to the root. But now we're going to look at x to the power of m to the nth root. I know this is starting to look a little crazy here. And this is always going to be equal to x. This number attached to it is going to be the numerator. This is the denominator. So that's the rule right there. The nth root of x to the m is the same as x to the power of m over n. So if I have 8 to the power of 2/3, that is equal to 8. Remember, this numerator is attached here. This is attached here. So this is equal to the cube root, 8 times itself, 64. What times itself is equal to 64. 4 times 4 is 16. 16 times 4 is 64. So this is equal to 16. Right here I have 27 to the 4/3. That 4 is attached to 27. And then this is the cube root of that. It's going to work out to be 81. Now this one right here, I have x to the power of 1/3 times x to the power of 5/3. My bases are the same. I am multiplying, so I add my exponents. I already have a common denominator of 3, so that gives me x to the 6/3, which is x squared. And then that's my solution right there. Next are some practice problems. Go ahead and pause the video, do these practice problems. Okay, on these practice problems, the first one is 16 to 1/2. I could also write that as the square root. The 16 attaches to the 1. The 2 is there, so it's really just the square root of 16, which is equal to 4. Another way to do this problem is take that 16 and see it's the same thing as 4 squared to the power of 1/2. Using the law of exponents, I multiply the 2 times 1/2 to get 4 to the first, or 4. Either way, you could do that. This 27 to the 2/3 is a tricky one. I mean, as a root, it would be the root of 27 squared and then the cube root of that. And I could figure it out that way. Take 27 times 27 and then look for the factors. Or I could see that 27 is a power of 3. 3 times 3, 9. 9 times 3, 27. So this 27 could be written as 3 to the 3rd, right? That's the 27 to the power of 2/3. I could multiply my exponents. These will cancel, and that's going to give me 3 to the power of 2, or 9. So on a standardized math test, you got to be able to realize this, especially when you're not using a calculator. X to the 10th to the power of 2/5. Go over here. to the power of 2/5. 5 goes into 10 twice, so this gives me x to the 4th. Right here, I have 9 to the power of 1/2. I have to distribute that half through the quantity. X squared to the 1/2. 2 times 1/2 is 1, so it's x. This is saying the square root of 9, which is 3, or just 3x. Lastly, that down here, number 8, let me move this up a little bit before we move on to the chapter test. So I got to distribute that -2/3 to the 8. 8 is also 2 times 2, 4 times 2, 8. So this 8 right here is 2 to the 3rd, a squared, all to the power of -2/3. So then that's going to be equal to 2 to the 3rd times -2/3 times a squared to the power of, or times -2/3. Here my 3's will cancel. That'll give me 2 to the power of -2 times a -4/3. I can make that positive by putting it down below. 2 squared in the bottom would be a 4. And then a to the 4/3 I could put down here 2 and make it positive and put a 1 in the numerator. They're pretty tricky. There's a lot there. But let's go ahead and take the chapter test now. So you want to pause the video, work your way through this test right here. Do the best you can, unpause the video, and watch how I do it. Again, this is a different notation, but this means right here, a to the 5th times a to the 3rd. Here I add my exponents to get a to the 8th. X to the 8th divided by x squared. That's my quotient rule. I subtract to get x to the 6th. Y to the 4th to the power of 3. Here I add, but here I multiply to get y to the 12th. Anything to the 0 power is equal to 1. Z right here to the -4th, I can make that positive by going 1 over z to the 4th. Okay, number 6, right there. So we have 3ab to the power of 2, 3ab, and that 2 is only attached, oops, sorry about that. That 2 is only attached here, and that whole thing is the power of 2. 3 to the power of 2 is 9. A to the power of 2. B squared, I multiply there, get b to the 4th. Right here, number 7, I have x over 5 to the power of 3. Not much I could do there. Really, that is just x to the 3rd over 5 to the 3rd. You can write out as 125. 5 times 5, 25 times 5, 125. Here I have c to the 7th times c to the -2. I add my exponents here to get c to the 5th. And number 9, let me rewrite this. I have 5a to the power of -2, b to the power of 3, and then this whole thing here is all to the power of 2. And that is times a to the 3rd, b to the -1. Those parentheses there are all to the 3rd. We distribute these exponents first by multiplying through. 5 squared is 25. A to the -4, b to the 6 times a to the 9th, b to the -3. That's going to give me a 25. A to the negative 4, a to the 9 is 5, a to the positive 5. B to the 6, b to the negative 3 is b to the third. That's a pretty hard one right there. But let's go ahead and do number 10 now. If you're still with me, you're doing a great job, working hard, getting these skills down. These ones right here, I mean, look at that. It just looks like crazy programming language. So I have x to the power of 1/2 times x to the power of 3/2, all divided by x to the power of -1. Let me just add these together first. I already have a common denominator. The bases are the same. I get 4 over 2, or x squared, over x to the -1. This is a little tricky here. Quotient rule, I'm subtracting 2 minus -1 is x to the 3, right? 2 minus -1 makes a positive x to the third. Great job if you're still here. Thank you for watching. You get this book by just clicking on that link. I decided just to make this open source or free of charge, and if you want to support the channel, please feel free to do that in different ways. And keep working at it, keep studying. We'll do well as long as we work together and keep working and practicing problems. Thank you.